Core drilling on reinforced concrete presents unique torque risks. I'm James Kitchen from DeWalt, and today we're going to run through how to safely use core drills when you can't see what's in the substrate. Some of the technologies in this video are unique to DeWalt, however the tips and tricks contained are universal. Please feel free to use the chapter markers in the description below to find the part of this video that is relevant for you. So the benefit of a core drill over the STS drill is the clutch in the back of this. The gyroscopic clutch has a unique benefit for a core drill that the STS drill doesn't. So it's measuring rotation over time, and it's that rotation over time which is clutching out the unit and keeping the user safe. The biggest challenge with an STS drill is that cuts out too quickly. So the gyroscope is actually measuring the degree of angle versus norm, which is when you pull the trigger. And if that's done over a certain period of time, it will cut out. So it allows the bit to carry on working even if it is struggling a little bit without stopping the machine. So this is the newest of the DeWalt FlexVolt core drill range. This contains the anti-rotation technology that we discussed. So that anti-rotation is using a gyroscopic sensor, which is sensing when the drill moves across an axis. Essentially it resets when you pull the trigger. So wherever you've got this positioned, whether it be upside down, back to front, it senses that default point, and as it binds, it will then sense where it's going, and once you hit a certain angle, that will then cut the machine off. So we're using a wet core. So as part of a wet core, we'll normally use a dust suppression system, so that's keeping the dust levels low by essentially wetting it so it doesn't become airborne. This is our wireless tool controlled water tank, and that will sync with the trigger, will essentially start as you pull the trigger on this tool. What we also have here is our drill stand. So this is designed for sort of smaller cores. As you go to bigger cores or above waist height, that's where this comes in. This fastens to the substrate and allows you a lot more control, and it means you're not trying to manhandle that machine into place. So in terms of PPE, you're going to need ear protection, whether it be in ear or over the head. You're going to need a mask, whether it be full face or just over the nose and mouth. You need a pair of goggles or safety specs, and you're going to need a pair of gloves. So in terms of application, there's a couple of things we need to be aware of. Always have two hands on the machine. Not trying to be a superhero, one hand these things. These are quite dangerous, there's a lot of torque here. Always braced, always stanced. And when you're offering up to the workpiece, you want the bit in, hand in line, with the hole you're trying to make, and a properly braced position. What you don't want to do is be chucked off the position that you sat in, because the drill is then turning and pushing you away from where you want it to be. What you also don't want is skipping from the workpiece and making a hole in the wrong place. So in the demonstration that we just carried out, the anti-rotation technology was actually forced into action through my own actions rather than the bit binding. We did this to show the LED light going off and to show what would happen in result of a binding core bit. As you saw from the video, what we did was we backed off, let go of the trigger, gave it a second, span it back up and re-entered the core drill into the hole. What that allows it to do is just reset the system and let the drill carry on cutting the hole as we needed to. As we saw in that scenario, the anti-rotation technology was actually stops the drill immediately, and the aim of that was to prevent injury. As with all core drilling, what tends to happen is that the core will bind immediately, and the rotation will carry on taking you with it. As we saw in the video, it took quite a long time to drill the 4-inch hole through that rebar and concrete substrate. It's really important that we pay attention to our bodies when we're doing that. The point of contact for the user is through their wrist, and there's quite a lot of performance going through this machine that's going to provide a lot of fatigue back to the user. What tends to happen is you tend to then want to try and force the drill bit through the substrate. That has a twofold issue. The problem at the handle point, so it increases vibration, but also user fatigue because we're now forcing the bit through. But it also dulls the diamond, and as soon as you start dulling the diamond, it increases the time to drill the hole. And if you increase that time to drill the hole, it also increases the vibration. So although the anti-rotation technology will prevent the user from being injured in the case of a bind, what it won't do is reduce vibration back through to the user, and that is a secondary problem that we explore in further video series. So to summarise, we've gone through how to drill a core hole, we've gone through the PPE required and safety features that you should be looking for in a tool, whether it be mechanical, electrical or gyroscopic clutches. That information is relative to most brands, but it's important that you have a look at the manual before carrying out any task with a tool to make sure you're using the right tool for the right application. If you're using a DeWalt tool, please go to our DeWalt website and follow the To Help You or customer service element and you'll be able to pull the manual. If not, it will be in the box. Keep an eye out for more videos in this series, including one about anti-vibration. And don't forget to like and subscribe for more practical engineering guides.